So next I am going to properties of Fourier transform. I am going to properties of Fourier transform. So the first property, I will give you statements, linearity property. Second one, time shifting property. Third one, frequency shifting property. Then the fourth one is time scaling property. Fifth one, convolution property. First I will finish this, then I will go to the sixth one. I am going with the property statements. Proofs are not required. We are not discussing proofs, only statements I will give you. If x1 is a signal, it is having Fourier transform x of j omega. This double-sided arrow indicates Fourier transform pair. Time domain x1 of t, frequency domain x1 of j omega. And second signal x2 of t. Its Fourier transform is x2 of j omega. This is if condition. Then a into x1 of t plus b into x2 of t. B into x2 of t. The Fourier transform is a into x1 of j omega plus b into x2 of j omega. A into x1 of j omega, b into x2 of j omega. This is the Fourier transform. This is called linearity property. Now I am going to time shifting. Property. If x of t is a signal, if condition. If x of t is a signal, it is having Fourier transform x of j omega. Then time shifting property means in time domain we are having a small shift in the signal. Frequency domain, it will be e power minus j omega t naught into x of j omega. That x of j omega will be as it is. The shift will come in terms of one exponential factor. Okay. Now I am going to the third property. Frequency shifting property. If x of t is a signal, it is having x of j omega. This is if condition. Then condition. Frequency domain, there is a shift. Omega minus omega naught is there. Then in time domain we will have e power plus j omega naught t into x of t. This is the frequency domain. We are having omega naught a shift. So in time domain there will be an exponential factor, equivalency exponential factor, which will give the shift. Okay. Now I am going to the fourth property, time scaling property. So if x of t is a signal, its Fourier transform is x of j omega if condition. Then if x of at is the signal, then 1 by mod a x of j into omega by a. This is the frequency domain. If time domain at is present, frequency domain we will have 1 by mod a x of j omega by a. Now I am going to the next one, convolution property. If x1 of t is a signal, it is having Fourier transform x of j omega, and x2 of t is another signal, its Fourier transform is x2 of j omega. This is if condition. Then in time domain, if we are making convolution between them, frequency domain we have to multiply the equivalent Fourier transforms. frequency domain, we have to multiply the equivalent Fourier transforms. Okay. For x1 of t, it is x1 of j omega. For x2 of t, it is x2 of j omega. Time domain star symbol is convolution. Frequency domain, it is equivalent to multiplication. Time domain convolution means frequency domain multiplication. These are the 5 properties. I am going to 6th property, Fourier transform property. So the statements will come for internals. Statements may be asked. Next, the 6th property, after convolution. After convolution, so we have differentiation property. After convolution, we have differentiation property. Then the 7th one is integration property. 7th one is integration property. And probably the last one is Parseval's theorem. It is another property. Parseval's theorem, another property of Fourier transform. Another property of Fourier transform. I am going to the 6th one, 6th property. Differentiation property. We have 2 things in this: differentiation in time domain, differentiation in frequency domain. Differentiation in time domain. Differentiation in time domain. This is one case. Second case, differentiation in frequency domain. Second case, it is differentiation in frequency domain. And if we go with this time domain, differentiation in time domain, if we have x of t is the signal, x of j omega is the Fourier transform, x of t, x of j omega, this is if condition. Then condition, we have to take time domain differentiation. In time domain differentiation, frequency domain, it is j omega into x of j omega. J omega is an additional factor, j omega into x of j omega. Now I am going to frequency domain, differentiation in frequency domain. If x of t is the signal, its Fourier transform is x of j omega. X of t is the signal, its Fourier transform is x of j omega. Then condition, in frequency domain, we have to take differentiation. In frequency domain, we have to take differentiation. Variable is omega, so I am putting differentiation with respect to omega. Time domain, what will happen? Minus jt is the factor along with x of t. Minus jt x of t, this is the time domain equivalence. Frequency domain differentiation is there. Frequency domain differentiation is present. Okay. So now I will go with integration property. Integration also, we have time domain integration, frequency domain integration. In time domain, if integration exists. In time domain, if integration exists, what will happen? In frequency domain, if integration exists, what will happen? In frequency domain, if integration exists, how to proceed? Okay. I am going with the time domain. If x of t is the signal, its Fourier transform is x of j omega. Then in time domain, you do integration. And the frequency domain, it will be 1 by j omega x of j omega. 1 by j omega x of j omega. Okay. And this is for 0 to t. Integration limits are 0 to t. This is the case. Now in frequency domain, integration is there. If x of t is the signal, its Fourier transform is x of j omega. This is if condition. Then condition, we have to do integration in frequency domain. Okay, integration variable is omega, so I am writing d omega. Then in time domain, it will be minus 1 by jt x of t. Minus 1 by jt x of t is the time domain equivalent. Okay. Here also limits are 0 to omega, something like that. It starts from 0 to omega. Okay. Now in time domain itself, there is another case. This is first case. If I take second case in time domain, if condition, x of t, x of j omega is the Fourier transform. Then condition, if the limits are minus infinite to t, negative limits also present. negative limits also present, x of t dt, then its Fourier transform will be 1 by j omega x of j omega plus pi into del of omega x of 0, small x of 0, which is initial condition, small x of 0, which is initial condition. Okay, this complete second term is initial condition because limits are going on negative side also, minus infinite to t. Okay, this is about time domain. There are two cases, frequency domain one case, and now I am going with last property, Parseval's theorem. Last property, Parseval's theorem. It says that energy is conserved both in time domain and frequency domain. Energy is conserved. It remains the same both in time domain and frequency domain. Both in time domain and frequency domain. Both in time domain and frequency domain. It is like this: integration mod x of t whole square dt, minus infinite to plus infinite. This is called energy calculation in time domain, energy calculation in time domain. If you are going with frequency domain 1 by 2 pi and you are having the frequency domain x of j omega modulus square d omega and limits are minus infinite to plus infinite. Okay, this is frequency domain energy calculation. And if you are using mod x of j into 2 pi f, if you are using f term, and here it is df, here it is df, this 1 by 2 pi will get cancelled, 1 by 2 pi will get cancelled. This is also frequency domain, second term, third term is also frequency domain, but this omega, if you write it as 2 pi f, that 2 pi and this 2 pi will get cancelled. The differentiate, integration variable d omega, integration variable d omega, in the place of omega, if you write 2 pi f, 2 pi is constant, so you can take it outside. So numerator 2 pi, denominator 2 pi will get cancelled, df will come, and x of j omega, x of j 2 pi f, one and the same, exactly 100% it is one and the same. X of j omega, x of j 2 pi f, it is one and the same. It gives the meaning that capital X is a function of f, capital X is a function of omega, nothing else. It is just giving a explanation that capital X is function of omega, capital X is function of f. Okay, so these are energy equations in time domain and frequency domain. Energy is same, that is our intention. Energy is same, that is our intention. That is called Parseval's